Missile defense is a system, weapon, or technology involved in the detection, tracking, interception, and destruction of attacking missiles. Conceived as a defense against nuclear-armed intercontinental ballistic missiles, its application has broadened to include shorter-ranged non-nuclear tactical and theater missiles. The United States, Russia, China, India, Israel, France, and Taiwan have all developed such air defense systems. In the United States, missile defense was originally the responsibility of the U.S. Army. The U.S. Missile Defense Agency has developed maritime systems in command and control that will eventually be transferred to the Navy and Air Force for operation and sustainment. Missile defense can be divided into categories based on various characteristics: type, range of missile intercepted, the trajectory phase where the intercept occurs, and whether intercepted inside or outside the Earth's atmosphere. These types, ranges include strategic, theater and tactical. Each entails unique requirements for intercept, and a defensive system capable of intercepting one missile type frequently cannot intercept others. However, there is sometimes overlap in capability. Targets long-range ICBMs, which travel at about 7 km per second. Targets medium-range missiles, which travel at about 3 km per second or less. In this context, the term theater means the entire localized region for military operations, typically a radius of several hundred kilometers. Defense range of theater defensive systems is usually on this order. Examples of deployed theater missile defenses: Israeli Arrow missile, American THAAD, and Russian S-400. Targets short-range tactical ballistic missiles, which usually travel at less than 1.5 km per second. Examples of currently deployed tactical ABMs: American MIM-104 Patriot and Russian S-300 volts. Ballistic missiles can be intercepted in three regions of their trajectory: boost phase, mid-course phase, or terminal phase. Intercepting the missile while its rocket motors are firing, usually over the launch territory. Advantages, disadvantages: intercepting the missile in space after the rocket burns out. Advantages, disadvantages: intercepting the missile after it re-enters the atmosphere. Advantages, disadvantages: missile defense can take place either inside or outside the Earth's atmosphere. The trajectory of most ballistic missiles takes them inside and outside the Earth's atmosphere, and they can be intercepted in either place. There are advantages and disadvantages to either intercept technique. Some missiles such as THAAD can intercept both inside and outside the Earth's atmosphere, giving two intercept opportunities. Endoatmospheric anti-ballistic missiles are usually shorter-ranged. Advantages, disadvantages: exoatmospheric anti-ballistic missiles are usually longer-ranged. Advantages, disadvantages: given the immense variety by which a defense system can operate, there are some unarguably effective exoatmospheric countermeasures an attacking party can use to deter or completely defend against certain types of defense systems, ranges of ACBMs, and intercept locations. Many of defenses to these countermeasures have been implemented and taken into account when constructing missile defense systems. However, it does not guarantee their effectiveness or success. The U.S. Missile Defense Agency has received scrutiny in regards to their lack of foresight of these countermeasures, causing many scientists to perform various studies and data analysis as to the true effectiveness of these countermeasures. A common countermeasure that attacking parties use to disrupt the efficacy of missile defense systems are the simultaneous launching of decoys from the primary launch site or from the exterior of the main attacking missile itself. These decoys are usually small, lightweight dud rockets that take advantage of the interceptor sensor's tracking and fool it by making many different targets available in an instant. This is accomplished via the releasing of decoys in certain phases of flight. Because objects of differing weights follow the same trajectory when in space, decoys released during the mid-course phase can prevent interceptor missiles from accurately identifying the warhead. This could force the defense system to attempt to destroy all incoming projectiles. which masks the true attacking missile and lets it slip by the defense system. Since there can be many forms of this type of deception of a missile system, different categorizations of decoys have developed, all of which operate and are designed slightly different. Details of these types of decoys and their effectiveness were provided in a report by a variety of prominent scientists in 2000. This categorization of decoy is the most similar to the standard understanding of what a missile decoy is. These types of decoys attempt to mask the attacking ICBM via the release of many similar missiles. This type of decoy confuses the missile defense system by th.